Okay, so this is the first day where we're actually going to calculate probabilities for anything other than 1, 2, or 3 standard deviations above and below the mean. Tonight's homework is on page 39 and 40, so make sure you take a note of that. I would like you in your groups to spend 5 minutes doing this question below. It's going to take you a good 5 minutes to try and work your way through it. Let's see what you can come up with, and I'll show you how to do the correct answer in a minute. So please pause the video. All right. We need to find an average here. So we're finding an average of 10 quizzes here. So we're just going to divide by 10 here. Whoops. This is saying that each quiz was worth 80 points. So 80 times the number of those quizzes plus 60 points at least on each quiz. So every other quiz. So 10 minus 1. 10 minus x, sorry, equals an average of 70. So the question is, how many of you guys came up with that? And that is what we need to solve this problem. So this is, and again, you don't need this formal formula to come up with it. If, I assume many of you found a way to figure this out without it, but this is the formal formula. So 80x distribute plus 60 times 10, 600. Minus 60x. And then you cross multiply your 10 and your 70 there, and you get 700. So 80 minus 60 is 20x plus 600 equals 700. So 20x equals 100. So there were a total of x equals 5 tests that he could have, with maximum number of times Jake could have earned 60 points on that to get the average of 70. Okay. You are on page 33 in your packet now. Why be normal? So please read the top portion of that. It'll take you a minute or so. So read that right now and pause the video. All right, you have two students, what I call student A and student B. Student A took the ACT and scored 29 in mathematics. So that student scored 29 on the ACT. You found from below that the ACT is normally distributed with a mean of 21 and a standard deviation of 5.3. Student B scored an SAT score of 680 in the, I believe this is the math section. And the scores on the SAT are normally distributed with a mean of 516 and a standard deviation of 16 in that year. So based only on the test scores, which student would you choose? So the way I teach this is I teach it by calculating a z-score. A z-score tells you the number of standard deviations that you would have scored above or below the mean. So if you did better than someone else, that means you scored more, a higher z-score. The calculation for z-score, z equals x minus the population mean, that's the symbol for population mean, over the population standard deviation. So student A would have had a z-score of 29x minus 21 population mean over the standard deviation of 5.3, or had a z-score of 1.51. Student B would have had a z-score of 680, which is x, minus 516 over 116, or a z-score of 1.41. So who did better? Who had the higher z-score? So it would have been student A. So in terms of graphically what this means, remember that in your normal curve, wow, it's a horrible looking normal curve, but the inflection point is 1 standard deviation above the mean. So that's 1. So we are at like 1.41 and 1.51. So if 1.51, which was student A, scored better than student B. You can see it graphically. Okay, keep reading down below and on to the next page, please. They're showing you, you can make comparisons on the that's the 68, 95, 99.7 rule. She drew that to find out what that was. It's similar. I'm going to just get to the point down here. Having extreme difficulties here. Let's see if I can do it this way. No. All right. So we have Jack with a z-score of 1.41 and Jill with a z-score of 0.89. All right. We are now going to teach you how to find these areas here. You know, it's probably later that they want you to learn it in this packet, but I'm going to just kind of teach you how to do it now. So if we have a z-score for Jack of 1.49, there is a chart in your packet on page 37 and 38. You can look up the 1.49 by going to the 1.4 row that says 1.4 and the column that says 0.09. So you go across 1.4, and this is on the positive side, and go over the 0.09 and you get 0.9319. Now, when you look up in the chart reads from the left. So that would be the number that's, or the percent that's scored below Jack. To find out the percent that's scored above Jack, remember, if we're at 1.49 standard deviations, get another lovely curve. Say it's about here, 1.49 standard deviations above the mean of 0. And we know that this area here is your 0.9319. Then we know the area under all density curves and including normal curves is 1. So 1 minus 0.9319 is going to be the percent that's scored above Jack, which is 0.0681. Now, I do this in my calculator. In your calculator, then you don't have to use the chart. You just have to think your way through the problem. I use what's at second distribution. So press your second key, get your calculators out. Press the second key and the key that says VARS. That means behind that is distribution, VARS. And that is like under the arrow keys. If you go to second VARS, you're going to go to number 2. That says normal CDF. And then they want you, it depends on your calculator now. There are 4 things it wants. It wants the minimum, the maximum, the mean, and the standard deviation. So min, max, mean, standard deviation. Mean and standard deviation are going to be 0 and 1, and they're going to stay that way for you for a while. So the minimum value is a very, very small here. Your maximum value is your z-score of 1.49. And again, your minimum has to be a teeny tiny little number. So I usually use -1 e to the 99th to mean my teeny tiny little number. And when you put that in your calculator, -1, whoops. And again, yeah, it could be like -1,000 you use. That's fine too. So you do -1 e, it's second ln to find e, to the 99th power, comma, 1.49. And it's going to give you 0.9319, which is, you know, it rounds to the same value as what we got here. To find greater than, again, you can do this directly, normal CDF of the minimum. The minimum now is 1.49, and we're going to the right. So 1.49, so that's the percent that's scored above Jack. To a very big number, you can use 1 e to the 99th power, or like, you know, 5,000, some big number. And then this just 0 and 1. So again, the newer calculators ask for min, max, mean, standard deviation. The older calculators, it just shows up as normal CDF with a parentheses. And then you fill in these numbers. So when you do this in the calculator, normal CDF of 1.49, 1 e to the 99th power, comma 0, comma 1. If you don't want to put 0 and 1 in, it's fine because it assumes it. It's 0.0681, which is the answer we got. Now we're looking at Jill. So Jill's, gotta find Jill's z-score. I apologize, I did this earlier. Where's Jill's z-score? Oh, I apologize. Jill's z-score is 0.89. So right here is our curve, and she scored 0.89 standard deviations above the mean. So we want to find what percent scored below Jill. So this is the area to the left of that z-score, and scored above is the area to the right. So again, one thing you could do is you could use your chart and look up that looks like a 0.39, 0.89, because her z-score is 0.89. So you can do this two different ways. One way is to go to the chart on page 37 where the numbers are positive when you have positive z-scores. Go to the column that says 0.80 and go across to that's the row, the column that says 0.09. So go 0.8. It doesn't say 0.80, it just says 0.8. And then over to 0.09, and it gives you 0.8183. Sorry, 8133. And that is the percentage written as a proportion. Again, that's 81.33%. In probability, percent, proportion, like it's pretty much interchangeable, but that's the percent that scored below Jill. And then obviously the ones that didn't score below Jill scored above Jill. So 1 minus that 8133 would give you that, which is going to be 0.1867 or 18.67%. If you're using the calculator instead of the chart, you're using normal CDF for negative 1 e to the 99th power, 0.89, comma 0, comma 1, and you'll get that exact value. And again, for greater than normal CDF, for 0.89, and a very big number, you can use 1 e to the 99th power, or 10,000. 0 and 1 also is going to give you that same value here. So you'll get these same answers written as decimals. What's percentage of test takers scored between Jack and Jill? This is where the calculator is fantastic, because Jack, again, is 1.49 standard deviation, and Jill is 0.89. I'm sorry for those strange lines. I don't know what they keep showing up. So in the calculator, you do normal CDF of minimum, which is 0.89, that's smaller, maximum, which is 1.49, comma 0, comma 1. Again, you can drop the 0 and 1 if you want, but the area in between is going to be 0.1186. If you're doing this the long way, and you're using the chart, you have to subtract 0.9319, which is the area below Jack, minus the area below Jill, which is 0.8133. And you should get that same answer. So again, calculator's fine, chart's fine, either one. Jack and Jill's friend Jason scored negative 1.49. Find the number of test takers that scored above him without using a table or technology. So one thing you could do is look at your 68, 95, 99.7 rule and approximate from there. I am going to go ahead and use technology because I don't like really guessing at things like that. So negative 1.49 is going to give you, let's see, the percentage that scored above him. So we're going to do normal CDF, for that's the minimum, 1 e to the 99th power, and 0 and 1. Or what you have to do is look up the negative 1.49, and the negatives again are on the back side, which is page 40. And then since it's to the right, you have to subtract from 1. The calculator will give you the answer directly, 0.1522. That's not correct. That's not even possible. What did I do? There we go. Sorry. I think I just put the wrong thing in. 0.9319. Again, if you're doing this by chart on the back, you look at negative 1.4 for the row, 0.09. And if you're looking up that way, negative 1.4 for the row, all the way to 0.09 is 0.0681. And then you have to do 1 minus 0.06. 1 minus 0.0681, and that's the answer we have. But they didn't ask how many test takers. They asked, they didn't ask the percentage. They asked how many. So you would then take that number and multiply it by how many people took the test. Down below. Again, there are other methods for doing that. Again, they're now introducing the z-score. If you have an ACT score of 23, the mean is 21, standard deviation is 5.2. What's the z-score? So z is going to be equal to 23 minus 21 over 5.2. You did better than the average, so you expect a positive z-score, which is 0.38. Just use and then they said formula, figure it out. I'm just jumping straight into that formula. Most people who are asked to do this without a formula do realize that they subtract and divide. So compare A and B. We just did it that way instead of doing it twice. We did that on the other page. Homework is page 39 and 40. So please start that right now. Reviewing up here some very important concepts. Let's see, are we there yet? No. Okay, so this is reviewing. Total area in a curve is 1. The area to the left of z equals 0 is 0.5, so 50% to the left, 50% to the right. And we have already gone through how to use a table, and then we jump into the homework. So homework is on page 39 and on page 40. And that's it. Thank you.